Okay, so what are topics? Thermodynamic, thermodynamic processes. So in thermodynamic process, first, what is the first name? What is the first process?
Isobaric process.
Isobaric. So which property remains constant here?
Pressure, sir.
Pressure. Very good. Pressure is equal to constant. What is second process?
Isochoric.
Isochoric process. Which property remains constant?
Volume.
Volume. Change in volume during the process is constant. Change in the volume is zero actually. Change in the volume is zero, but
Yes, sir.
volume at first point and second point is same. What is third?
Isothermal.
Okay. So which property remains constant during the process?
Temperature.
Temperature is equal to constant. Just you remember the hint, okay? Bar is a unit of pressure, so pressure is constant. Choric is related to volume, volume is constant. T for temperature, temperature is equal to constant. Fourth one, adiabatic. Okay, here there is no property remains constant, no, but what will be the constant? No exchange of heat. Heat
There is
exchange
no
is,
exchange of heat.
yes sir, heat exchange is zero. Heat exchange where? Between system and surrounding. Okay, heat exchange is zero. So between device or machine, from the machine to the surrounding, no exchange, heat exchange, or from surrounding to machine, no heat exchange. Last one is polytropic process. So this class is very important, my dear students, to solve numericals. Okay, I will be explaining the equations as well as some important points related to thermodynamic numericals. Okay, first point, what I will explain in all these cases. Okay, PV diagram. How to draw PV diagram for this? P means pressure. It should be straight line. Okay, V means volume. Straight line. Pressure versus volume diagram. So one more diagram will come, that is TS diagram. What is TS? Stands for T for temperature, S for entropy. Okay, S for entropy. Okay, so I need to tell one more point here when it comes to entropy. Dear students, look at the point number 4. Point number 4 is adiabatic. The reversible adiabatic. Okay, I'm adding one more word. Reversible adiabatic process is also called isentropic process. Remember this point. Reversible adiabatic is called as isentropic process. So in isentropic process, which property remains constant? Try to understand, try to split this word isentropy. In this word, you are saying one property: pressure, volume, temperature, enthalpy, entropy. Like ಈ ವರ್ಡ್ ಅಲ್ಲಿ ನಿಮಗೆ ಒಂದು ಪ್ರಾಪರ್ಟಿ ಕಾಣ್ತಾ ಇದೆ. ಏನ್ ಪ್ರಾಪರ್ಟಿ ಇದೆ ಇದರಲ್ಲಿ? ಎಂಟ್ರೋಪಿ. ಇಲ್ಲಿದೆ ನೋಡಿ. Entropy is also a property, just like pressure. Pressure is also property, volume is property, temperature is property. So entropy is constant. The process in which entropy is constant throughout the process or during the process, that process is called isentropic process. Okay, ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ, S is equal to constant. ಬೇಕಾಗುತ್ತೆ. Okay, I will use this concept in solving numericals. Okay, so coming back to the PV diagram. Okay, First, I will represent isobaric process in the PV diagram. Isobaric means constant pressure. Iso means same. It is a Greek word, my dear students. Iso means same or constant. So process in which the pressure is constant or pressure is same. So that process is called isobaric process. So how to represent on the PV diagram? P is pressure, V is volume. How to represent constant pressure? Horizontal line or vertical line? Constant pressure, for example, it is 0, 0 bar, 1 bar, 2 bar, 3 bar, 4 bar, 5 bar, so on. And during the process, it should be constant. So how will you represent process here? Horizontal line or vertical line? It should be constant. 1 bar, 2, 3. Just an example I am telling you. Okay. It should be constant. The process is at 1 bar. So isobaric process at 1 bar. So you should have to represent it with horizontal line. So this is beginning of the point, beginning of the process, point 1. This is end of the process, point 2. So during 1 to 2, the pressure is constant. So in this graph, how much is the pressure? How much is the pressure at point number 1?
5
5
bar.
bar. Okay. How much is the pressure at the end of the process? After end of the
5 bar
process, that
itself,
is
sir.
5 bar. So here it is, pressure is constant. Constant pressure, that is 5 bar. Okay. So dear students, remember point number 1 is initial point of the process or final point? Point number 1. It is initial point. Point number 2, it is a final point. Okay. And if you take the volume, V1 is initial volume, V2 volume at point number 2. Now if you plot a graph of this curve, this line, V1 is initial volume. It may be 0.1 and V2 may be 0.5, 0.1, 0.2, 0.3, 0.4, like this. Okay, this is x-axis, 0, 0.1, 0.2, 0.3, 0.4. Just an example I am telling you. Okay, these values will be given in the numericals. Okay, understood now? First point is you have to write pressure is equal to constant. Second point is the process should be represented with horizontal line, and here also you write pressure constant. So during this process, the pressure is at the initial point, it is P1. At the final point, it is P2. So P1 is equal to P2 during this process. Okay, this is second. The one more point what you need to remember here is N value. N, that is Polytropic Index. Polytropic Index is N. Adiabatic Index will be represented with which symbol? Symbol for Adiabatic Index?
Sir, yes.
Gamma. Gamma. Okay. Remember, adiabatic index will be represented symbol gamma, like this gamma. Polytropic process or polytropic index will be represented with the letter N, small n. Okay, lowercase n. Okay. Next. And here the value of n is 0. Keep in mind, if someone asks you in the interview, what is a polytropic index for isobaric process? You should say n is equal to 0. N is equal to 0. Okay. All these are all new points, new concept you must remember. Okay. Within thermodynamics. Okay. Next, what we need to remember here is, okay, I will give one hint. Okay. PV to the power of gamma or PV to the power of n is equal to constant. You remember this. Okay. You can ask a question. So this equation, it is for which process? So someone has asked you in the last class, sir, why should you write for polytropic? Which property remains constant? If they ask for definition of polytropic process, so polytropic process, it is a process which satisfy or which obey the law PV to the power of n is equal to constant. Okay, what is the definition of polytropic process? And here there is property is not constant. Any property will not be constant. Here PV to the power of n, the law is called as polytropic process. Any process which obey, which satisfy the law PV to the power of n. Okay, dear students, I think you know a little bit of mathematics knowledge here. If you substitute n is equal to 0, what will get in this equation? P V to the power of 0 is equal to constant. What will get? V to the power of 0 is what? Any value to the power of 0, it is equal to 1. So 1, pressure is equal to constant, you will get. That is the reason I said here n is equal to 0. Why I said n is equal to 0? If you put n is equal to 0 in this equation, you will get the pressure is equal to constant. Okay. Now second process, isochoric process. So isochoric process is volume is equal to constant. So volume is on x-axis. So during the process, the volume is 0.1 meter cube. So then means initial volume is 0.1 meter cube, final volume is also 0.1 meter cube. And how will you represent in the PV diagram? Vertical line or horizontal line? Initial point and final point should lie on the same line. Vertical or horizontal?
Horizontal, sir.
Horizontal, it is for isobaric. Horizontal means pressure will be constant. I need volume constant. Vertical line. Vertical line. So point number 1 is initial point. Point number 2 is final point. So now you do not look at this 1 to 2. It is over. It is for isobaric only. You look at only for this vertical line. So in this vertical line, initial point is V1. Okay, V1 is equal to 0.1. So here volume is same. The process ends at point number 2. What is the volume at point number 2? 0.1. That is 0.1. Okay, here volume is equal to constant. You need to write. We need to write the volume is equal to constant. And the next point is n value. What is the n value for this isochoric process? Is n is equal to infinity. You start from 0. Here is a 0 value. 0, 1, 2, 3, 4, 5, 6, so on. And the last number is infinity. So n is infinity for isochoric process. Remember, my dear students, they may ask you in the interviews and all, what is a polytropic index for constant volume process? What is a polytropic index for isochoric process? Isochoric is constant volume, so n is equal to infinity. Okay, next. Okay, next. Third process, isothermal process. So in this isothermal, temperature is constant. So how to draw that constant temperature process in PV diagram is, dear students, one more hint I will give. Please listen carefully. This hint is very important. When you are plotting PV diagram, what I'm saying, when you are plotting PV diagram for any thermodynamic process, ಯಾವುದಾದ್ರೂ ಇರಲಿ, constant pressure idre horizontal. If it is constant pressure, you write horizontal. If it is constant volume, you write vertical. other than these two, ಅಂದ್ರೆ constant pressure and constant volume ಬಿಟ್ಟು, if any process is there, draw with curved line. That's it, like this. Okay, you draw a curved line like this. So this is initial point is point 1, initial point, initial starting or initial process, final process is point 2. ಅರ್ಥ ಆಗ್ತಿದೆ ಅನ್ಕೊಂಡಿದ್ದೀನಿ ನಾನು. ಏನು ಹಿಂಟ್ ಅಂದ್ರೇನು, ಪಿ ವಿ ಡಯಾಗ್ರಾಮ್ ಹಾಕ್ಬೇಕಾದ್ರೆ, ಯಾವುದೇ ಪಿ ವಿ ಡಯಾಗ್ರಾಮ್ ಹಾಕ್ಬೇಕಾದ್ರೆ ಪ್ರಾಸೆಸ್ಗೆ ಕಾನ್ಸ್ಟೆಂಟ್ ಪ್ರೆಷರ್ ಅಂತ ವರ್ಡ್ ಬಂದ್ರೆ ಹಾರಿಜೆಂಟಲ್ ಲೈನ್ ಹಾಕ್ಬೇಕು, ಕಾನ್ಸ್ಟೆಂಟ್ ವಾಲ್ಯೂಮ್ ಅಂತ ಇದ್ರೆ ವರ್ಟಿಕಲ್ ಲೈನ್ ಹಾಕ್ಬೇಕು. ಇವೆರಡು ಬಿಟ್ಟು ಬೇರೆ ಯಾವ್ದಾದ್ರೂ ಥರ್ಮೋಡೈನಮಿಕ್ ಪ್ರಾಸೆಸ್ ಕೊಡ್ಲಿ ಅವರು, ಅಂದ್ರೆ ಟೆಂಪರೇಚರ್, ಪಾಲಿಟ್ರಾಪಿಕ್, ಅಡಿಯಾಬೆಟಿಕ್, ಐಸೆಂಟ್ರೋಪಿಕ್, whichever may be the process, you have to represent with curved line. Okay, this is graph. Now this point is for isothermal. Now you can ask for what should be the value of n. N is equal to 0 for constant pressure, that is isobaric. We should get n is equal to 1 here. N is equal to 1 for isothermal. Remember, ಇವೆಲ್ಲ ವ್ಯಾಲ್ಯೂ ನೆನಪಿಟ್ಕೊಳ್ಳಿ. isothermalಗೆ n is equal to 1. And next one is adiabatic. Fourth one, adiabatic. This is first process, second, third is isothermal is over. Fourth one, adiabatic ಬಂದಾಗ n value is equal to gamma ಅಂತ ಕರಿತೀವಿ, that is 1.4. This is for adiabatic. And last one, polytropic, that is for third. N is equal to n. It is greater than 2 but less than infinity, just like. Okay, it will be greater than 2. It may be 3, 4, 5, 6, like that. Okay, if you don't know the value of n, it may be infinity, then it is constant volume process. ಅರ್ಥ ಆಗಿದೆಯಾ? ಏನ್ ಕನ್ಫ್ಯೂಷನ್ ಇದೆ ಇಲ್ಲಿ ಯಾರಿಗಾದ್ರೂ? ಯಶ್, ಡು ಯು ಹ್ಯಾವ್ ಎನಿ ಕನ್ಫ್ಯೂಷನ್? ಗಗನ್, ಏನ್ ಕನ್ಫ್ಯೂಷನ್ ಇದ್ರೆ ಕೇಳಿ, ಹೆದರ್ಕೋಬೇಡಿ. If you have any confusion in this, again one more time you watch this video and you will get you will clear all the doubts. Okay, because this is the first time you are attending thermodynamics, you feel it is little bit tough, okay, but ಆತರ ಏನಿಲ್ಲ, ಇದು ಸ್ವಲ್ಪ ಇನ್ನೊಂದ್ಸಲ ನೋಡಿದ್ರೆ ಅರ್ಥ ಆಗ್ಬಿಡುತ್ತೆ. ಇಲ್ಲಿ ನೋಡಿ ಇನ್ನೊಂದ್ಸಲ. Okay, now I will write some equations. And dear students, first and the best equation, you remember this, PV to the power of n is equal to constant. First you remember this equation, always you remember this equation. All remaining equations are based on this. I will give a hint how to remember. If n is equal to 0, if you put n is equal to 0, what you will get? P is equal to constant. P is equal to constant means isobaric process. Okay, next time again I will write the same equation. I will write PV to the power of n is equal to constant. Put n is equal to 1. Okay, if you put n is equal to 1, what you will get? You will get equation PV is equal to constant. Correct or not? Constant means some value.
Yes, sir. Yes.
Constant means some value. Okay, so this is equal to this is equal to means this is for which process? Isothermal process. So why I'm writing all these equations are, these equations will be used for numericals. Okay, in the numerical he will give isothermal process. The volume is 0.1 in the beginning, volume is 0.5 at the end, pressure is 1 bar at the beginning. Calculate pressure at the end of the process. He will give V1, he will give V2, he will give P1, and he may ask you to calculate P2 for isothermal process. V1 will be given 0.1, V2 will be given 0.5, and he may ask to calculate P2, and P1 will be given 2 bar. What you will do for isothermal? You apply this equation at point number 1. P1 V1 is equal to constant. This is at point number 1. Same equation you write at point number 2. Point number 2 means end of the process. Point number 2 is end of the process. That is final process. Here is a final. Here is point number 2 is final. End of the process is final. Okay. So point number 2, I will equation, I will write P2 V2 is equal to constant. So right hand side constant means same value. Here is also some value, same value is reflecting here, constant. Right hand side is same, then obviously left hand side will be equal to each other. So based on this, P1 V1 is equal to P2 V2 is an expression for isothermal. Here V1 is given, substitute as 0.1. V2 is given, substitute as 0.5. P1 is given, substitute as 2 and calculate P2. So to calculate such type of unknowns, we'll be using this equation. Not only this equation, similarly this equation also. Pressure is equal to constant. Okay. Now I will write one more equation. PV to the power of gamma is equal to constant. If I write like this is for which process, my dear students? Whenever I read gamma, this is for
Adiabatic.
adiabatic process. The same, he may ask you to calculate adiabatic index value or pressure. He will give V1, he will give V2, he will give P2, and he may ask you to calculate P1. In this case, how will you write? First you write this equation at point number 1. How will you write? P1 V1 to the power of gamma is equal to constant. This is at first point, initial point. Similarly, you have to write the second point at same equation, adiabatic index equation, adiabatic process equation at final point. Final point is 2, constant. Okay, right hand side is same. Obviously, left hand side values will be remain same. So P1 V1 to the power of gamma is equal to P2 V2 to the power of gamma. Here V1 is given, substitute here. V2, substitute here. P2 is given, substitute here, and he is asking P1. You can calculate P1 using calculator. And one more point, always you remember, gamma value is 1.4. This is adiabatic index. Adiabatic index, that is gamma, is equal to 1.4. If this value is given in the numerical, you use it. Otherwise, you have to remember this value. Okay, sometimes he may give 1.2, 1.3, but standard value is 1.4. Understood? The last one more equation is same. PV to the power of n is equal to constant. What is n, student? My dear student, here, what is n?
N is
Polytropic index. Polytropic index. You understood now? This is little bit tricky. Please watch this video once again and you will understand all this process. It is very important to solve the numericals. First, I request you to write the name of the process. What is the assignment? how you have to, this question, how they will ask in the question is, in the VTU exam or in the semester exam or in the internal, how the question will be asked: list all thermodynamic processes, write the value of n, the right value of adiabatic index, or sorry, polytropic index for all thermodynamic processes. Okay, and in the same question they may ask you, represent all these thermodynamic process in a single PV diagram. In a single PV diagram. This is single PV diagram. Why it is called single PV diagram means all 5 processes I have represented in the same PV diagram. If they ask you to draw separately, how will you draw? Pressure versus volume. This is for constant pressure, initial point, final point. And for second process, how we need to draw separately PV diagram and TS diagram? PV, this is constant volume, separately. They may, but 90% they may ask you to draw the separately, other because it is time consuming. They may ask you to draw all process or represent all process in a single PV diagram. Single means all process you should draw in the same PV diagram. And this is for constant temperature 1 to 2. Separately, if you there, if they ask for separately, you draw like this. Otherwise, this is a diagram. How the question will be asked in the exam? List all thermodynamic processes and draw the PV diagram for all thermodynamic processes in a single PV diagram. What is the condition? Condition is, consider initial point is same for all processes. Look at the PV diagram here. Point number 1 is same. I am assuming, it is not a condition that always it should be same. I am assuming point number 1 is initial point for all the process. Nodili, point number 1 is same for first process. Point number 1 is initial point for second process. Point number 2 is same for third process, fourth process, and last, fifth process. Okay, this is for 10 marks. List all thermodynamic processes means first you have to write all thermodynamic processes. Then you have to write definitions. After writing definitions, you draw PV diagram considering same initial point, not single, same initial point. Initial point ಎಲ್ಲದಕ್ಕೂ same ಇರಬೇಕು, and represent in PV diagram. And also you have to write n value for isobaric, n value for isochoric, n value for isothermal, adiabatic, and polytropic. If you have any doubts, you can ask me. Okay, please watch this video once again and clarify your doubts. You can ask me in the comment section. You can call me and ask. Okay.
Yes, sir.